Um, Hello, hi Ahmad. I'm gonna go through the slides now to explain the presentation. The topic actually is performance analysis of FFT and Gozel algorithm for DTMF detection. First of all, let me tell you what FFT means. Um, FFT means fast Fourier transform. Fast Fourier transform. So I'm gonna try to fast Fourier transform is a mathematical method for signal analysis that was invented by Fourier. I'm just gonna Google it so that you see fast Fourier transform. Yeah, this is called fast Fourier transform. It's a method for analyzing signals. So now we want to compare it with Goetzel algorithm and see which is better for DTMF detection. DTMF means dual tone multi-frequency. When you press a number on your phone, maybe one, it's what happens is that the phone is going to send a signal that contains two frequencies. That's why it is called dual tone. Dual means two. So, for example, if you are doing what do you call it? Maybe maybe telephone banking, or you are trying to pay for something online and they say okay, or okay, yeah, go something like maybe you are talking to a mobile network. You want to recharge you want to top up your phone by um automatic from your phone. You don't want to type in the voucher. um so you could just say you could start responding to the voice activation that says if you want to recharge, press 2. If you want to use voucher, press 3. If you want to press that the number, those kind of stuff. So as you're pressing those numbers, what happens is that each of the number 0 to 9, A, B, C, D, hash, star, they have what they call a DTMF signal. So each one has two frequencies. So when you press 1, a signal that contains two frequencies will be sent away. Now, what happens at the receiving side? We want to be able to detect that tone and see if it's actually 1. So we should be able to detect the frequencies that are inside the original DTMF signal. So that is why we need method like FFT and Goetzel. So which of them is better? This is what we are going to consider now. So dual tone multi-frequency is a telephone push button signaling technique that is used to transmit a phone number or any combination of telephone keypad buttons to a central telephone office where the appropriate DTMF signal is detected and necessary required action taken, such as connecting to a telephone call or to the appropriate person, for example. Now, basically, if you call a number, if I dial your number on my phone, now what happens? The entire signal, we have to go to the central base station, which will now connect me to you. It has to be able to detect the frequencies on each number of your phone number. So each number that I'm pressing, maybe if your number is 07524, when I press 0, when I press 7, when I press 2, when I press, each of those digits have their own DTMF. So at the receiving side, the base station is able to detect DTMF and then know that, okay, I'm trying to connect to this particular number. So I'm just going to show you the matrix now. This is a simple 16 entries, 4x4 matrix of DTMF signals. Now this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, star, hash, A, B, C, D. This is column frequency, row frequency. So that means if I press number 1, the signal that will be generated will have frequencies of 697 and 1209. So on the receiving side, I should be able to detect these two frequencies. If I can detect these two frequencies, I will know that the number that was pressed is 1. For 2, it's going to be 697 and 1336, just like that. For D, it's going to be 941 and 1633. So, for example, this is button 5 result in 770 Hz and 1336 Hz tone being generated simultaneously. That's button number 5, 770 and 1336 Hz. See? So if at the receiving side I'm able to detect these two frequencies, I will know that it is number 5 that is pressed. So don't mind that stuff showing on my screen. I don't know, it's some Windows whatever. So let's look at the two algorithms, FFT and Gozell. DTMF can be detected with FFT or Gozell. Any of them can be used to detect DTMF. But the problem that we discovered from this comparison between the FFT and Gozell is that FFT, which is the fast Fourier transform, is going to calculate more discrete Fourier transform. Now, basically, both the Gozell algorithm and the FFT use what they call discrete Fourier transform. Well, you don't need to know much detail about that, but it is also it's a form of Fourier transform that is used for analyzing discrete signals, that's digital signals. So both of them use DFT for sure. But the problem is that FFT we calculate a lot of DFTs before you can detect DTMF. But Gozell will calculate only 16 DFTs because Gozell is interested in only the 16 numbers, whereas FFT we calculate DFT for the full spectrum. So because of that, FFT will take a lot of time. Takes more computational time to detect DTMF. So basically, the best to use is Gozell because Gozell is faster. Now, what is Gozell? To implement Gozell algorithm, the following equations are required. Qn equal to Sn plus 2 cos 2 pi k over n Qn minus 1 minus Qn minus 2. This is a recursive method. If you check, this is also Q, but Qn minus 1, Qn minus 2. Alright, and then if Qn is given by this, the output is given by this expression. Right, these are just referenced equations, so you don't need to know their derivations. Doesn't matter. So this is the output of the Gozell algorithm. So based on these equations, we have this particular Gozell filter structure. This is like the Gozell filter. So you have the input here, the input signal. You have the output that is detected. Now this whole block is a representation of these equations here. So actually, we are not so interested in the core of the Gozell algorithm. We just want to see how it is performing and compare it with FFT. That's the main idea. Because in MATLAB, we already have functions that implement Gozell algorithm. So we just use the functions and then apply them to signals and try to compare with FFT and see which one is detecting DTMF more, which is better. So FFT and Gozell, I want to compare them again. FFT is an optimized discrete Fourier transform which can be used to detect DTMF tones. The Gozell algorithm, on the other hand, is better implementation of FFT, such that less computational time is used for detection of DTMF. But FFT will calculate the DFT for the whole spectrum, while Gozell is only for the required frequencies. Like I said before, just 16 frequencies, 0 to 9, A, B, C, D, and star and hash. This is what Gozell will do. But FFT is going to calculate a lot of DFT which are not necessary, and that's going to make it more time consuming. So remember, our goal is to detect DTMF, and then we want to compare using both FFT and Gozell, which is better. So I'm going to show you some simulation result now. Now this simulation result was plotted from MATLAB each of the symbol was plotted. You see, this is 1, symbol 2, symbol 3, 4, 5, 6, 7, 8, 9, star, 0, hash. I just did um, 0 to 9, star, and hash. Now, if you check, each of them have their frequencies. For symbol 1, remember I told you the frequency is 697 and 1209. If you go back, you see that 697 and 1209. So what I just did simply is to tell MATLAB to plot a sinusoidal signal that has these two frequencies. You know, just use these two frequencies, add them together and plot the signal, and then this is what you get. Now, if you observe this signal, is so rough like this. They are all very rough signals, and we cannot easily see the frequency inside right now. But at the receiving side, this is what is transmitted. DTMF signals transmitted. At the receiving side, we need to know which frequency is inside this rough wave, that is this sinusoidal wave that is kind of scattered now. I want to know which frequency is inside. So I need to do some transform to see what is inside. I can use FFT or I can use Gaussian. So this is what we are trying to do, since we want to detect which of them is better. So let me show you FFT detection. Now look at FFT detection. For symbol 1, if you see, there is a frequency close to 702 here, which is around 697, which is very high. So 697 is detected. But the next frequency is 1209. 1209 is around here. But if you observe, there is another one that is high, a little bit high. Okay, look, in this detection, what we are interested in is the high amplitude, the frequencies with high DTMF magnitude. So let's look at this is the tallest. So we can say, okay, this one is one of the frequency, which is correct, 697. But the problem here is that how do I know the next one? Because this one is high, 780. This 1210 is also high. I think these two are the tallest, the next tallest ones. So you see the problem with FFT now, because FFT is going to calculate a lot of spectrum, and then we get confused which frequencies to use. Now when you come to number 2, we have 697, which is here, which is high, yeah, and around 1336, which is here, which is high. But we also have other smaller frequencies which can confuse the receiver. So if you see with FFT now, although we have the main frequency showing as high, the main frequencies are high, but the problem is we also have many other frequencies which we don't really want. So you see why we are able to detect the main frequency in DTMF with FFT. With Gaussian, we will be able to get it better. So I'll show you Gaussian now. Let me go to the Gaussian one, the next one. Now check Gaussian. You see, all other frequencies are just almost 0. Only what we need are high. See, we only have 2, 697 and 697 and 1336, just like that. So if you see with Gaussian, we only have 2 high frequencies, which is the frequency we are trying to detect for each of the DTMF signal. Whereas in FFT, we see a lot of other frequencies that we don't need. So this brings a lot of computational problem. This needs a lot of we need more hardware to implement filters to remove all these unwanted signals. So we have been able to see that Gaussian is faster and more accurate than FFT. So in conclusion, more accurate result is obtained from Gaussian algorithm than FFT. Gaussian is faster than normal full spectrum FFT. Gaussian requires less computer time to detect DTMF, and in general, both are based on discrete Fourier transform, but Gaussian has a better implementation for DTMF detection. So I'll just summarize and wrap up again. What we are trying to do is that we are trying to detect DTMF signals, and we are trying to check, is it better to use Gaussian or FFT? And we find out that Gaussian gives a better results. Thank you.